So we just saw all about the matrix transpose, and next we are going to see all about the matrix Hermitian conjugate. So let's go to the notes. So this is the last thing we saw, matrix transpose, just swap the rows with the columns, and we saw that the dot product can be written as a matrix operation. Now we're going to see the Hermitian conjugate. Okay, so you have a matrix A. The Hermitian conjugate of this matrix is written as a dagger, as a superscript. Now, what did I say? Dagger? So dagger is this symbol. Yeah, it's called the symbol dagger because it resembles an actual dagger. Okay? So this is a dagger, which means the A Hermitian conjugate. And what does it mean? It's actually very simple. It's simply you get A and you do the complex conjugate, which means you do the complex conjugate of every element in A, and then the result of that, you transpose it. So you can say that the Hermitian conjugate of a matrix is just the complex conjugate of the transposed matrix. Yeah. Okay, because actually this could be, we could say if we want that you first transpose it and you later do the complex conjugate. The result is the same. Okay. Now, this dagger operation has some properties, the same as the transpose had. So for instance, if you do a product A times B and you do the dagger operation, then this can be written as B dagger times A dagger. And once again, be very careful because these two are swapped. And this is very easy to prove by using the property for the transpose. Yeah. So you have to swap those. Why is the dagger used very often? Because it can be used to write the inner product as a matrix operation. So let's imagine we have two vectors, A and B. Now these are vectors that we write as a column, but the same as we did before, we could imagine these vectors to actually be a matrix. Yeah. So this would be a 3 times 1 matrix, if you want to. Yeah. So what would be a dagger? So a dagger would be A transposed and then complex conjugate. Okay, so a dagger would be a 1 times 3 matrix that has AX conjugate times AY conjugate, sorry, not times, AY conjugate and AZ conjugate as the 3 elements. So this would be a 1 times 3 matrix. Yeah. And this is very convenient because it means that we can write the inner product between A and B, between vector A and vector B, as a dagger matrix multiplication times B. Right? Because that would be AX conjugate, AY conjugate, AZ conjugate times, let me get some space here, times vector B. And the result of this matrix multiplication would be AX conjugate times BX plus AY conjugate times BY plus AZ conjugate times BZ, which is equal to A conjugate dot B, which is the Hermitian inner product that we saw in chapter 1. Only one thing to remark here is that maybe you were thinking that the inner product was A dot B conjugate. You were conjugating the second vector, not the first one. Well, I did tell you that there were 2 ways of doing it, 2 conventions. Yeah, the mathematicians usually use this convention here, but the physicists usually use this convention here, where you conjugate the first vector. And when we use the physicist convention, I told you that I would use a stick instead of a comma when I'm writing the inner product. Yeah. So if you use the physicist's convention, then you can write the inner product between vectors A and B as A dagger times B. Yeah, so it makes it very convenient to do proofs and so on using the dagger instead of having inner products. And we will do that later. Okay. Now, find the Hermitian conjugate A dagger of the matrix A. So let's do an example. So you have a matrix A, this is equal to 1, 2, 1 plus I, 3I, and 0. What would A conjugate be? So not the dagger, let's do the conjugate first. So the conjugate, you just have to do the conjugate to each element, yeah? So it would be 1, 2, 1 minus I, minus 3I, and 0. So notice you have to flip the sign of the imaginary part of every number. If the number is real, such as 2, you don't have to do anything because there is no imaginary part. If the number is 0, there is no imaginary part, so you don't have to do anything. Okay? So that's the complex conjugate of A. So what would A dagger be? A dagger would be the complex conjugate transpose. So we need to transpose this second matrix here. So that would be the following matrix. 1, 2, 1 minus I, minus 3I, 0. And that would be A dagger. So notice that the first column became the first row, and the second column became the second row. Or, equivalently, you imagine the mirror trick. Yeah? Okay, so that's the dagger, the Hermitian conjugate of a matrix. Thank you very much for listening.